Now, coming to the general principle number 3, assessment of restorability. Although it is tempting to develop an endodontics mode, although it is tempting to develop an endodontics mode mindset once root canal treatment has been diagnosed, another major objective is to check the restorability of the tooth prior to the root canal treatment. Existing restorations carries an unsupported enamel and dentin should be removed and the remaining tooth structure should be examined under a microscope. The operator should search for the presence of cracks, height and thickness of the remaining dentinal walls for failure effect, and the thickness of the remaining dentinal walls for failure effect, and the thickness of the remaining dentinal wall for failure effect. The relationship of the remaining coronal tooth margins relative to the osseous crust. The relationship of the remaining coronal tooth margins to the osseous crust, root length, location of the furcation, amount and quality of attached gingiva, amount and quality of attached gingiva, and position of the tooth in the arch. This can result in several advantages. Before root canal treatment is started, the patient can be forewarned of risks, benefits, and alternatives of any further procedures and or costs to restore the tooth completed. For example, crown lengthening and gingivectomy, extrusion or placement of orthodontic bands. 2. A more educated opinion on long-term prognosis can be provided by the clinician to enable the patient to choose whether root canal treatment or implant therapy is more beneficial. And 3. Leakage of bacteria back into the root canal space under a pre-existing defective restoration can be prevented. And cracks on the remaining tooth structure can be more readily assessed. This may change the clinician's decision to extract versus restore, to place build-up immediately, to perform cuspal reduction, or warn the patient more empathetically of the chance of fracture post-operatively, or warn the patient empathetically, more empathetically. Empathy is to feel the pain and to think besides the patient and saying empathy, showing empathy towards the patient, or warn the patient more empathetically of the chance of fracture post-operatively. However, in certain situations, it can be argued that a portion of the restoration should be left in place until the root canal treatment is almost completed. However, in certain situations, it can be argued that a portion of the restoration should be left in place until the root canal treatment is almost completed. This provides a circumferential matrix to enable a seal by the rubber dam or help hold the clamp in place as long as no leakage can be seen under higher magnification. A more difficult situation arises when an existing crown is present on the tooth that requires endodontic treatment. As accessing to a crown has several distinct disadvantages. The amount of the remaining tooth structure, the quality of the build-up restoration, the extent of any decay, and the quality of the crown seal cannot be thoroughly assessed. In fact, Abbott found that there was less than 60% chance to detect caries, fractures, and marginal breakdown without complete removal of the restorations. All, this all of these factors have a profound effect on the long-term success of the root canal treatment and longevity of the tooth. However, it is impractical to suggest removing all crowns prior to the root canal treatment. However, it is impractical to suggest removing all crowns prior to root canal treatment, and therefore a careful assessment of the integrity of the crown must be attempted through history taking and clinical examination before and during treatment. Therefore, a careful assessment of the integrity of the crown must be attempted through history taking and clinical examination before and during treatment. Now coming to the general principle of the preparation of coronal and radicular spaces. Number 4 principle is straight line access, which is the most important one. It is well documented that to prepare the apical third of the canal circumferentially, a straight path for the cutting instrument from the orifice to the apex is imperative. As the curvature of the canal increases, a file that enters into the canal is deflected at its tip by the force exerted by the dentin. However, according to the Newton's law, the file tip exerts back an equal and opposite reaction upon the dentin, that is, force on the outer dentinal surface of the canal as the file attempts to straighten back to its original dimension. If the dentin exerts a greater force than the file, the file bends, but this changes as the file size increases. But if the dentin exerts a greater force than the file bends, but this changes as the file size increases. Eventually, the file will cut the dentin rather than bend. At this point, the outer dentinal wall of the curvature is cut, preferentially known as gouging, which is the start of ledging and transportation. Zipping, which is the start of ledging and transportation. Ledging in the root and transportation in the crown part. This effect is accentuated with the cutting tip files compared with non-cutting tips, and with a vertical filing motion versus rotational motion. This effect is accentuated with means clearly appreciated with cutting tip files compared with non-cutting tips, and with a vertical filing motion versus rotational motion. A concomitant problem develops as the file tip exerts a force back on the dentin. A fulcrum point develops, which is the most protuberant point of the contact on the furcal dentinal surface. Therefore, preferential cutting occurs on the furcal surface also. The site of a most common procedural error known as stripping that can lead to perforation. Therefore, a differential cutting occurs on the furcal surface, right? Not on the non-furcal surface. Therefore, a preferential cutting occurs on the furcal surface also. The site of a most common procedural error known as stripping that can lead to perforation, not said the gouging, not said the ledging, not said the transportation. He said that the stripping at the furcal area that can lead to perforation. The term straight line axis (SLA) describes a preparation that provides a straight or outwardly flared unimpeded path from the occlusal surface to the apex. This allows the file to reach the apex with minimum deflation. We can see in the figure 1. This is the figure 1 showing straight line axis in a mandibular third molar. In picture A, you can see the orifice opening means the canal orifice opening and path of insertion pre-operatively is indicated by a black line. The mesial and the path of insertion pre-operatively is inserted by a black line. The mesial wall have to be cut to obtain a straight line axis. You can see in this picture the pre-operatively how the straight line axis should be there is shown by a black line. In this, the mesial wall has to be cut to obtain a straight line axis, right? And the picture B showing the handles of the files are standing upright without crossing over each other, indicating adequate straight line axis. In picture B, you can see there is the handles of the files are standing upright. The handles of the files are standing upright without crossing over each other, indicating there is adequate straight line axis. And in the picture C, however, often the distal canals are angled such that the file handles project out of the orifice mesially while still maintaining a straight line axis. In picture C, you can see the distal canals are angled. The distal canals are angled such that the file handles project out of the orifice. The files handles project out of the orifice mesially while still maintaining the straight line axis. This allows the file to reach the apex with minimal deflection. The main, the main corollary is that it has to be accomplished without compromising the vertical surface of the canal that could ultimately lead to strip perforation, that could ultimately lead to stripping, that then lead to perforation. Access is continually Access is continually adjusted until the selected master apical file MAF. The axis is continually adjusted until the selected master apical file MAF reaches the working end without undue stress upon it. The axis is continually adjusted until the selected master apical file reaches the working length without undue stress on it. A more aggressive straight line axis is required as the size of the file used and or the degree of canal curvature increases. A more aggressive straight line axis is required as the size of the file used and or the degree of canal curvature increases. Means when the file size is increasing, you require more aggressive straight line axis, and the canal curvature is more, then you should have more aggressive straight line axis. In this context, aggressive suggests that the orifice wall In this context, here the aggressive suggests that the orifice wall leading to the canal has to be moved and flared more obtusely toward the corresponding line angle. Aggressive suggests that the orifice wall leading to the canal has to be moved and flared more obtusely toward the corresponding line angle. The diameter of the apical preparation also affects the axis preparation. The diameter of the apical preparation also affects the axis preparation. To prepare a larger apical diameter, correspondingly larger, stiffer files that have a stronger tendency to straighten the canal have to be taken to the apex in order to avoid stripping on the vertical surface or transporting the apex. One must achieve straight line axis beforehand. Unfortunately, the literature does not provide a consensus on the ideal apical diameter. Unfortunately, the literature does not provide a consensus on the ideal apical diameter. Ideal apical diameter. Consensus on the ideal apical diameter. However, in vitro studies have measured canal diameters. Other studies have measured Other studies have measured canal cleanliness of a small versus larger diameter apical preparation and have shown better cleanliness with larger diameters with larger diameters. One study, however, found that improvement gained with larger diameters was not statistically significant. However, one study, however, found that improvement gained with larger diameters was not statistically significant and concluded that small apical diameters were sufficient for adequate bacterial reduction. Radiographically, canal curvature in the mesodistal plane. Radiographically, canal curvature in the mesodistal plane can be directly observed. However, Cunningham and Senia demonstrated that canals possess a three-dimensional curvature. Therefore, to obtain a straight line axis, sometimes tooth structure must be removed more on the buccal on. Therefore, to obtain a straight line axis, the uh, therefore, to obtain a straight line axis, sometimes tooth structure must be removed more on the buccal or on the lingual surface than just on the mesial or distal surface. Right? Straight line axis involves the selective removal of the outer canal tooth structure to protect the furcal surface. Various methods have been advocated for this. The so-called anti-curvature filing. The so-called anti-curvature filing involves cutting only the outward stroke away from the furcal surface, but is not effective beyond curvatures. Gate-Glyden rules. Gates-Glyden burrs, that is GG burrs, allow the selective removal of dentin when used with a laterally directed motion, and similarly stiffer nickel titanium rotaries have significant lateral cutting ability. Peters et al., using microcomputed tomography, have shown that significant portions of canals are not touched during instrumentation due to the irregularities and curvatures of the canals. This reiterates the importance of achieving the straight line axis. Mannan et al. Tested whether straight line axis would allow mechanical cleaning of all the walls of the root canal in a single rooted anterior tooth with a simple root canal anatomy. They prepared three types of access cavity designs. 1. A lingual cingulum just coronal to the cingulum, and 2. A lingual conventional where the cavity was extended to within 2 mm of the incisor edge, and 3. An access cavity involving the incisal edge but not the labial surface. They found that none of the cavity designs allowed complete planning of the They found that none of the cavity designs allowed complete planing of the root canal walls, although the incisal edge design allowed a greater proportion of the root canal walls to be filed than the other two. This study, however, determined the MAF size, master apical file size, as 3 sizes larger than the first file to bind. The study, however, determined the master apical file size as 3 times as the study, however, determined the master apical file size as 3 times as the study, however, determined the master apical file, that is MAF size, as 3 sizes larger than the first file to bind. This study, however, determined the master apical file, that is MAF size, as 3 times larger than the first file to bind. which had already been shown by other researchers to be an ineffective technique to properly clean the two apical canal third. This study, however, determined the master apical file size as three sizes larger than the first file to bind, which had already been shown by the other researchers to be an ineffective technique to properly clean the apical canal third. Another possible deficiency was that they did not extend the access cavity onto the labial surface, which is often necessary for true straight-line access as shown earlier. Another possible deficiency was that they did not extend the access cavities onto the labial surface, which is often necessary for true straight-line access as shown earlier. Previously, they have stopped the access cavity on the lingual surface and lingual surface and incisor edges and only the incisor edges, but not extending into the labial surface. However, this study did emphasize that straight-line access provides the best chance of debridement of entire canal.